Good morning, good afternoon, good evening, students. Welcome back to my channel. This is AP Macroeconomics with Mr. McRitchie here. Today we're going over one of the more tricky concepts for students to understand in Unit 1, which is absolute and comparative advantage. Now, if you've got good math brain, you will love this because it's pretty doable. It's mostly just playing around with ratios, which a lot of students kind of miss doing. It was a part of math that you guys tended to have pretty good ideas for, where it's like, 3 over 2 is the same as 15 to 10 and stuff like that. Like, there's a lot of like that kind of thing. And there's also going to be talking about one of the more critical questions we have in economics, which is, okay, we have that production possibilities curve, which gives us different amounts of things to produce. We know there's the allocative efficiency there, which is like the best point based on what society wants. But if there's more than one person who can produce things, which in the real world there's more than one business that makes your good, there's more than one country that can produce the products, how do we determine which of those is the best? The most common answer to that is who can make the most of it. But that's not always the case, because if we were to think raw production power, a country like the United States could certainly produce more chocolate than the Ivory Coast. However, the Ivory Coast produces a lot more chocolate than us. Why? It's not just because they have the natural resources. We could easily do that too. We are a very large country that has a lot of parts of it that would be appropriately climatized to do that. If we were to just put our resources towards making chocolate, I'm sure we could make more than that small country in Africa, but we don't. So why? Why do we choose to produce differently? And it has to do with this concept called comparative advantage. The idea being that you don't always produce what you can produce the most of. You produce what you can produce at a lower opportunity cost. The idea being, whenever you're making a choice, it always costs you an opportunity. But when you're a large country, the scale of that opportunity cost is much higher. So when you're making that choice, that cost is a lot higher if you're a country like the United States versus a country like the Ivory Coast that doesn't have a lot of other options to produce, whereas America has an insane amount of other options that are very likely to be more profitable than just raw chocolate production. So that's what we're getting into today. It's talking about that idea, and for the most part, practicing the math of it, because this is the most math-intensive thing in Unit 1, and takes a few tries to get handled. So as I go through practice problems on this video, guys, I do strongly recommend you copy down what I'm doing, and like the little charts and tables that I've got into your notes. You want to have at least like 5 or 6 of these problems in your journal, just so that you've got the reps of it, because it is a math thing, and you guys know doing a math thing once, you'll instantly forget it. Do a math thing twice, you'll have an idea for it. Do a math thing 12 times, you will not forget how to do it because of the trauma of doing so much math. Cool? All right, let's get started. So let me get the projector up and running, and go over there. Yeah. Make that a little bit bigger. Cool. So absolute and comparative advantage. This is a 2-video series because the first part we'll just be talking about absolute and comparative advantage. The second part we'll be talking about the thing that students tend to struggle with a lot more, terms of trade, which is applying this concept to then help us figure out good trade deals between countries. It's really cool. All right. So first, vocab. There's not a lot of vocab in this PowerPoint. There's really like 2 slides of real text you have to worry about. So if you hate writing words, this is an awesome set of notes for you. Absolute advantage and comparative advantage, what these terms mean. Absolute advantage is when you can produce more of something given the same amount of resources. All else being equal, if you've got 2 people making a thing and one can make more of it than the other, that person has the absolute advantage. It's just raw production power. So absolute advantage is kind of simple. It's just who can make the most if they have an even playing field. Comparative advantage is producing something at a lower opportunity cost given the same amount of resources. You give them both equal playing field here as well, but it's who's producing it at a lower opportunity cost. Sometimes this will be the same person, sometimes it won't. Like in the case of the United States versus the Ivory Coast, we have the absolute advantage in chocolate. We could definitely produce more of it than they could if we were to put all of our resources towards it. But they have the comparative advantage in it because they have a lot fewer other options, so their opportunity cost will be significantly smaller than ours. So the idea is simple. Who can produce more versus who can produce at a lower opportunity cost? These definitions are important to have down because given different parameters of information, you might be looking at a high number or a low number, and I'll get to that here in a second. But let's start with an example. So I teach juniors and seniors in high school, and the seniors like to brag about being good at stuff, so I like to throw them a bone here. We've got 2 things that the juniors and seniors can make. Reason why I'm sticking with 2 things here, like the production possibilities curve, is because of opportunity cost. Remember, opportunity cost is the second best option. So if there's like 3 or 4 goods they can make, I won't really be able to tell what exactly the opportunity cost is in these scenarios. If there's just 2, I can easily tell. So I've got the juniors who can make 2 cakes in an hour or 6 pizzas in an hour. I've got the seniors who can bake 4 cakes in an hour or 8 pizzas in an hour. Now, to be clear, these are either or statements. They can either do 2 cakes in an hour or 6 pizzas in an hour. They cannot do both. If you're imagining it like a production possibilities curve, it's like this is 6 pizzas and that is 2 cakes. So those are their endpoints. Those are their just maximums. And seniors can make 4 cakes in an hour or 8 pizzas in an hour. Simple question off the top. Who's better at baking cakes? Based on raw number, I would say seniors. Who's better at making pizzas? Based on raw number, I would say seniors. What I've just identified is the absolute advantage. Absolute advantage is your more simple version of who is better at producing something. So that's way too thick of a line. Let's go that way. There we go. So the absolute advantage belongs to the seniors in both cakes and pizza because they can make more. This is give them both an hour. The seniors can bake more cakes and make more pizzas. Cool? Great. Comparative advantage. This is where you got to focus up and watch me. Because this is where students will be like, wait, what the hell did he just do? So here's what I'm going to do. In order to compare, I need to figure out what the opportunity cost is for baking 1 cake. Right, I want to be able to compare both to each other. Because I want to see who can make it at a lower opportunity cost, right? So who's got the lower opportunity cost in producing cakes will be whoever has a lower cost of producing 1 cake. Which means I'm really finding the per unit opportunity cost here. I'm taking whatever I'm giving up, that would be 6 pizzas, over whatever I'm gaining, 2 cakes. 6 over 2, which I can simplify that down to 3 pizzas. Now, if the math confused you for a second, sort of zoom out of the math. Listen to what I'm about to say. Every time they bake a cake, they could have made 3 pizzas, right? If I'm looking at they could make 2 cakes in an hour or 6 pizzas in an hour, that means every cake they baked, they could have made 3 pizzas. Does that make logical sense? It should. Because if I'm doing like some like extra math here, it'd be like, okay, so 2 cakes in an hour would mean that it's taking them 30 minutes per cake. 6 pizzas in an hour means it's taking them 10 minutes per pizza. Okay, well in 30 minutes they could make 1 cake or they could have made 3 pizzas. So every time they bake a cake, it costs them the ability to have made 3 pizzas. What I did there is a nice little shortcut. It's OGO. I take the other column's number and it goes over my current column's number. So if I'm doing it on the bottom half, OGO, the opportunity cost of 1 cake for the seniors will be other, 8, over 4, simplify and or solve, that's just 2, which also makes logical sense. Every time they bake a cake, they would have been able to have made 2 pizzas. Okay. So remember that comparative advantage is who has the lower opportunity cost, and what I have found here is the opportunity cost of baking a cake for each group. The opportunity cost of baking a cake for the juniors is 3 pizzas. The opportunity cost for baking a cake for the seniors is 2 pizzas. So seniors would have the lower opportunity cost because it costs them less pizzas to make a cake. It feels really weird to say, but it's just a matter of like time resources, right? Now do the same thing for baking pizza. Do it yourself first. Track that you know what you're doing here. Find the opportunity cost of 1 pizza for each. I know a lot of you guys don't like to do the practices when I say, hey, do this. You just sort of like skip and don't pause the video. Trust me, for this, you want to pause the video and practice this skill as many times as you can. So find the opportunity cost of 1 pizza for each. Again, do the OGO model. So pause the video and attempt it. If you don't know what you're doing, then don't pause it. But if you think you have an idea what to do, pause it and test it and see if you know what you're doing. Okay, so it's my turn to show you how to do it. I'm going to take the other number and it goes over my current one. 2 over 6, which I can simplify down to a third of a cake. Because remember, the opportunity cost of a pizza will be some amount of cake. And then I do this one, 4 over 8. 4 over 8, which is a half. So every time the juniors baked a pizza, they could have made a third of a cake. Every time the seniors baked a pizza, they could have made a half of a cake. So the opportunity cost of making a pizza is a third of a cake for the juniors, and it's a half a cake for the seniors. Now here's the thing. Who has the comparative advantage in pizzas then? Who has the lower opportunity cost? Remember how fractions work, guys. That would be the juniors. Uh-oh. Seniors got real cocky. They thought they were better than juniors at everything. Not everything. But because the juniors are, and this is mostly because they're not very good at baking cakes, because they are not very good at baking cakes, it's not very costly for them to make pizzas instead. They have a lower opportunity cost in baking pizzas because a third of a cake is less than a half of a cake. They're giving up less every time they make a pizza than the seniors are. That's the idea here. So I've got a few things that I want to help you out with that are like nice little rules of thumb to save you time. Because this looks like a lot of work for a problem, right? This looks like I have to do like 4 math problems for each of these. That's a lot. There's some ways to save you some time. Firstly, I got 3 here, I got a third here, right? 3 and a third. Those numbers, for those of you math kids, those are called reciprocals. They're numbers where like it's a fraction that has been flipped, right? 3 over 1 and 1 over 3. We've got 2 and a half here. Same thing, reciprocals. They're always going to be reciprocals. So whenever you find the opportunity cost of one good, for that same producer, the opportunity cost of the other good will be a reciprocal. I have 4 in one, I should have a fourth in the other. I have 5 over 2 in one, I should have 2 over 5 in the other. Because that's the way I set up the problem, right? 6 over 2 and 2 over 6, 8 over 4 and 4 over 8. Those are just reciprocal problems. So that should be a nice time saver. You only really have to find this first row because the next row will just be a third and 1/2. Also helps you double check your answers. Of like, wait a minute, they're not reciprocals. I messed up. I simplified wrong or something like that. The second rule, and this is important, this is something worth writing down actually. Because they're reciprocals, you cannot have a comparative advantage in both. Mathematically, that won't make any sense. The idea is if your number was bigger in one side and then you take the reciprocal of it, it'll be smaller on the other side. So like 3 and 2, 2 is less than 3, but if I take the reciprocals of each of those, a third is less than a half. Any combinations of numbers that you use, if you take the reciprocals of it, the high and the low will flip because I'm literally flipping the numbers. So a producer cannot have a comparative advantage in both. You can't have, because if it costs you less to make one good, it'll cost you more to make the other good. Because we're talking in terms of the goods themselves. That's the idea here. So you cannot have a comparative advantage in both, and the opportunity costs will be reciprocals. And those two are actually kind of connected ideas. In terms of anything else that's a good hint, something like that to save you time. The OGO thing will save you time here, but let's give you one more example before I move on to the next concept. So, I got Ford and Chevy. They can make SUVs and trucks. For you, time to test your brain and see if you know what you're doing. Find the absolute advantage and the comparative advantage. Who has the absolute advantage in SUVs? Who has the absolute advantage in trucks? Who has the comparative advantage in SUVs? And who has the comparative advantage in trucks? Pause the video and attempt this problem. Go. And we're back. Okay, if you wanted to watch me answer it, now's the time to watch me answer it. Absolute advantage is easy. It is who can make the most. Who can make more SUVs, Ford or Chevy? 10 is bigger than 8? Cool. I can do that math. So Ford has the absolute advantage in SUVs, and Chevy has the absolute advantage in trucks. Comparative advantage time. In order to find comparative advantage, you have to find the opportunity cost, because the definition of comparative advantage is who's producing it at a lower opportunity cost. I will always set it up like this, and I always write it like this too. I've seen students that just don't write this 1s equals thing, and they'll just write some amount of t. Those students get confused on, wait a minute, is the opportunity cost of SUVs this, or is the opportunity cost of trucks this? That's why I write it in the box. So whenever I'm given comparative advantage problems, I actually just copy down the table. I might abbreviate stuff like F and C and S and T, But I copy down the box because I like to work in it, because it helps me keep track of, oh, that's the opportunity cost of an SUV. So the opportunity cost of an SUV for Ford is other goes over. Again, it's OGO is the hint there. 15 over 10. If we simplify that down, I like to keep these in fraction form as a heads up because of the reciprocal thing. So that'd be 3 over 2 trucks. Every time they make an SUV, they're giving up 1.5 or 1.5 trucks. Yeah, that makes sense because they could make 10 or 15, so could have made 1 or 1.5. For Chevy, 16 over 8. I actually know that. I don't have to simplify that. That's just 2. 16 over 8. Oh, that's just 2. Cool. So I've got 2 trucks. I've got 3/2 of a truck. Weird, but sure. Which has the lower opportunity cost, Ford or Chevy. The opportunity cost for Ford of 1 SUV is 3/2 of a truck. The opportunity cost for Chevy of 1 SUV is 2 trucks. Lower opportunity cost belongs to Ford. That should be a D. So Ford has the comparative advantage. And then I go to the other side to do this one's opportunity cost. I can save myself time because I know they're reciprocals. So if this was 3 over 2, this should be 2 over 3. And if this was 2 on the left side, it should be 1/2 here. Again, technically what I'm doing for those is it's the opportunity cost of 1 truck is 10 over 15. Then I simplify that down to 2/3. And then it's 8 over 16, which is 1/2. But since I already solved this side, I can just take the reciprocal of each of these, and then bing, bang, boom, that's what it is. So lower opportunity cost here, 2/3, 1/2. 1/2 is less than 2/3, 0.5, 0.66. So Chevy has the comparative advantage in trucks. To be clear, just because you have the absolute advantage in something does not inherently mean you'll have the comparative advantage in something. It most of the time means that, but whew, sorry. Doesn't always mean that, but it does, typically. I wouldn't write it down as a rule, but it's a good thing to look at. Now, what you're being presented with for both of these problems, for the first 2 problems, is what's called an output question. It's worth writing down. It's an output problem, where the number in the numbers they're giving you, the numbers in the table, are the numbers of things being produced, like it was, pizzas and cakes, SUVs and trucks. On those problems, the way to find your comparative advantage is to take other goes over, this OGO thing, right? To find the opportunity cost, 1S equals other goes over, 15 over 10. So the opportunity cost of 1 SUV is 3 over 2 trucks. So OGO is the shortcut. Yes, write the shortcut down. Trust me, you'll want to write the shortcut down. And then write what it stands for, because kids write OGO and get confused. Other goes over. I take the number from the other column, it goes over my current one. There is a second type of problem you could see, called an input problem. So, output problem, numbers given to you are the number of things being produced given a set of resources. Number of pens and pencils, number of liters of Coke, whatever. Okay? If it's a number of things being produced, it's an output problem. Output literally means what you're putting out there. That's products. The other type of problem you'll see, which is what we're going to practice next, is an input problem, where the numbers in the table that you're presented are the amount of resources needed to produce a fixed amount of a product, like number of hours to make a thing. Like if it said number of minutes to make a pizza for the first example, right? That would have been an input problem, because the product, pizza, is fixed. It's 1 pizza. What's the variable, what's the numbers that can be different, would be the resource, time. Why that matters is because it will change the logic of our answers. So let me go back to that first problem real quick. If this said number of minutes to make, let's say hours. Number of hours it takes to make a cake. So they're both baking 1 cake. It takes the juniors 2 hours to bake a cake. It takes the seniors 4 hours to bake a cake. Real easy to see the thing here. Check the definition of absolute advantage again. It is who can produce the most given the same amount of resources. Given this modified version of the question, who can make more cakes? If I gave both juniors and seniors the same amount of time, who's better at making it from a raw number standpoint? Juniors are now. Because if it takes juniors 2 hours to make a cake and seniors 4 hours to make a cake, if I gave them both 24 hours, the juniors can make 12 and the seniors can only make 6. The juniors can produce more. That's a big deal because people see absolute advantage like, ooh, cool, bigger number, I got it. Not always bigger number. It's who can make the most given the same amount of resources. So when it's an input problem, the absolute advantage is sort of changing the scenario to who can produce it with the least amount of resources. Because if it's even resources, then whoever uses the least amount of them would be the one who can produce the most. In simpler terms, when it's an output problem, absolute advantage, you want the high number. When it's an input problem, absolute advantage, you want the low number. It's not because the definition of absolute advantage has changed. Absolute advantage is still who can produce the most given the same amount of resources. It's just when resources are the variable, which is what's happening in an input problem, who can produce the most would be who uses the least of the resource. And don't worry, I have extra examples to explain or to show you how that works. Is there like a tag on this? No. Okay. So I'm getting poked by anything on my shirt. Okay, so here's an example. This is the number of acres needed to produce one, let's call it barrel. I'm just picking a dumb unit. Number of acres needed to produce one big old barrel of apples, one barrel of pears. So what's the variable in this problem? Well, it's one barrel of apples, one barrel of pears, and that's the product. So the product is fixed. It's not changing. The variable here is acres. It's why I color coordinated it. And acres, land, is a resource. Remember that your resources can be a lot of different things. So in this case, the resource is acres. A good thing to do here when you're copying down the table is to like scribble like, hey, this is 10 acres and 6 acres. Not 10 and 6 apples. It's 10 and 6 acres to make one barrel of apples. Kids get caught because they don't want to read. You make mistakes in these problems because you're like, ugh, who cares about that bullet point above the question? It's 10 apples and 6 apples, idiot. It's like, no, it's not. You didn't read. That's on you. So Tom and Sam can make apples and pears. It takes Tom 10 acres to make a barrel of apples. It takes Sam 6 acres to make a barrel of apples. Who can produce the most apples? If I gave them both the same amount of land, who's making the most apples? That would be question. I'm asking you guys a question. Say it out loud on your computer. I could hear it. Yes, it was Sam. Sam has the absolute advantage in apples because it takes him fewer resources to make them. If I gave them both the same amount of land, say I gave them both 60 acres to mess with, Sam could make 10 things of apples. Tom could only make 6 things of apples because it takes him 10 acres per barrel. So he's not as good as Sam is. He just loses them. His trees aren't as nice. He does a bad job. Who can make the most pears? Still Sam. Because again, this is 2 and 5 acres, not 2 and 5 pears. So you gotta read the little statement up here carefully, and that's why I like to label like acres, 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 so I'm not like looking pears. Tom can make more! It's like, no. It's acres, so Sam can make more. Now, here's the second difference. There's 2 big change-ups that happen when it's an input problem. One, your absolute advantage is now the smaller number. The definition hasn't changed, though, so it isn't that big of a deal. The other big difference is finding comparative advantage. Comparative advantage's definition is still the same also. It still produces at a lower opportunity cost. But how I find the opportunity cost is different. On an input problem, I do OGU. Other goes under to find my opportunity cost. So let me show you what I'm doing with that. So what I'm doing there is I'm saying the opportunity cost of producing one apple is other goes under. So it ends up being 5 under 10, so 10 over 5, which would be 2. Now let's double check the logic of it, because you're like, why did he do OGU? That isn't what's happening there. Every time he makes an apple, it would have cost him 2 pears. You're like, what? It's like, oh, because it takes him 10 acres to make a thing of apples, only 5 acres to make a thing of pears. So if I gave Tom 10 acres, he could have made an apple, or he could have made 2 pears. I'm doing OGU to basically convert the unit from acres back to apples and pears. That's what I'm doing there. By flipping it, I'm actually like reorienting it back into the units of this, apples and pears, as opposed to acres. Now, if you don't like the math logic, cool, I don't really care. Just do the math logic every time and you won't mess up questions. I don't love how this logic works either, but I'm like, you know what, this does make sense after the fact of like, oh yeah, every time he makes an apple, he could have made 2 things of pears based on the numbers. Which means every time he makes a pear, he could have made, other goes under. It's still a reciprocal. That rule still applies. Doesn't matter if it's input or output. It's still reciprocal. Half an apple. Or half a barrel of apples. Again, give him 5 acres, could have made a thing of pears. Give him 5 acres, he can make half of a thing of apples. Logic checks out. Okay, find the opportunity costs for Sam using this OGU formula / pattern. Find the opportunity costs for Sam of 1 apple and 1 pear. Go. And again, pause the video when you're doing these so that you can like actually practice them. All right, unpause it. Here we go. Other goes under. 6 over 2 is 3. That's a great looking 3. And then 1/3 would be the way it goes over here. Oh, shoot, that should say, let me erase that. That should be a pair right there. There we go. Okay, so who has the comparative advantage in apples? Comparative advantage is still who has a lower opportunity cost, so that would be Tom. And then Sam has it for pears. So Sam has the comparative advantage in pears. Tom has the comparative advantage in apples. So, to be clear, and this is a thing to like, okay, process and now listen. So here's the thing you gotta understand. The definitions of absolute and comparative advantage did not change, going from an input to an output problem, back and forth. Definition of absolute advantage is who can produce the most given the same amount of resources. That's what the definition is. So if I'm looking at it here, if I gave Tom and Sam the same amount of resources, Sam could actually make more because it costs Sam fewer resources to make these things. So if I gave him the same amount of resources, Sam would create a larger quantity of each good, right? Now, comparative advantage is who can produce it at a lower opportunity cost. I have to try and figure out what the opportunity cost of producing an apple is. And since this is acres, I can't just go straight across the line OGO like before. I've got to kind of reorient it. By putting the number below instead of above, it actually mathematically reorients it for me. To tell me, oh, the opportunity cost of producing an apple is 2 pears, which checks out with this of like, oh, if I gave Tom 10 acres, he could have made an apple. If I gave Tom 10 acres, he could have made 2 pears. So that does make sense after the fact. So it's OGU for an input problem to find the opportunity cost. It's OGO for an output problem to find the opportunity cost. But the definitions of absolute comparative advantage have not changed at all. Just feels weird. Okay, all the stuff I'm saying here, if you want to pause on like things like here you can just pause on this and like read that. It's the same verbal explanation I just gave. Comparative advantage, mentioned that already. OGU, other goes under to find comparative advantage stuff. Okay, second thing. Second practice problem. You need to, first, figure out, is this an input or output problem? Second, solve for absolute advantage. Third, solve for comparative advantage. Prove to me you know what's happening. Because this is a thing that you need to practice, trust me. We've got XYZ core, we got QKFX core. These are the amount of days it takes for them to make a car and a plane. So pause the video, try and solve those 3 questions. Input or output, absolute advantage, comparative advantage. Go! Unpause. All right. So, input or output, number of days to produce 1 of each. Okay, what's the variable here? Is the variable the resource or the product? The resource is days, the product is cars and planes. It tells me these are the amount of days it takes to make 1 car and plane, so that means the product is the fixed thing. The resource is the variable. The resource is the variable. It's an input problem because resources are inputs and output is product. So it's an input problem. Cool. Absolute advantage time, which to be clear, this means this is 8 days. Oh, why did I get the tiny thin pencil? I hate that. Oh, ugh. That's terrible. No, give me a better pencil there. That's 8 days. 15 days. Yeah. Okay. This will help me figure out the absolute advantage very easily. So I'm looking at this like, okay, XYZ takes 8 days to make a car. QKFX takes 15 days to make a car. Okay, if I gave them the same timetable, XYZ could definitely make more cars, right? Again, it's an input problem, so you're picking the lower number for the absolute advantage, but I don't even think about it as a pattern. I just think about it based on definition of like, oh, it's who can make the most given the same amount of resources. If I gave them both the same amount of time, XYZ is making more. For this one, I got 10, I got 12. Okay, who's making more? That'd be still XYZ. They can make more given the same amount of time. If I gave both the same amount of time, XYZ is pumping out more planes because it only takes them 10 days to make a plane as opposed to QKFX's 12 days to make a plane. So I've got XYZ's got the absolute advantage for both. All right, comparative advantage time. It's an input problem, so what do I do, class? In OGO or OGU? Input, I do OGU. If it helps you to remember it, output starts with an O, so it's OGO. That's the only way I've been able to like really help people remember that. So, OGU for input problems, here we go. I need to find the opportunity cost of one car for XYZ. Take the other, it goes under, so that's 8 over 10. 8 over 10 simplifies down to 4 over 5. Yes, this is the part of the class that you get punished for not being able to simplify fractions. You should be able to simplify 8 over 10 down to 4 over 5 because 8 and 10 are both divisible by 2. But if you had a bad math teacher not explain how simplifying fractions works very well, you're on YouTube already. Just look up how to simplify fractions on YouTube. You'll find someone who can explain it pretty well. The internet's a good resource. Okay, the opportunity cost of one plane would therefore be its reciprocal time. If it's 4/5 here, it's 5/4 here. Now, if you're not amazing at simplifying fractions, I probably wouldn't do the reciprocal thing. I would probably manually solve each and make sure they're reciprocals. Because there's a chance some of you guys have not simplified fractions in a minute, because you guys are like in calculus and all that stuff, and you've been using calculators a lot, so you haven't been able to simplify fractions for a while. So if you're out of practice on it, if you need some extra reps, I wouldn't go like, oh, it's a reciprocal, so just flip it. Because if you messed up this one, if you got like 8 over 10 is 5 over 6 somehow, I don't know, happens, you guys have brain farts, then you'll put like 6 over 5 here and you get both wrong. So if you do both and you find that they are reciprocals, there's a really good chance you did it right. If you do both and you find that they're not reciprocals, there's an amazing chance that you messed up. There's a great chance that you did a bad brain thing, and you should just try it again and double check your math. Okay, for QKFX, the opportunity cost of one car is other goes over. Oh, this is a more interesting one. 12 over 15. Can I simplify that fraction? Yes, class, I can. That's divisible by 3. That's also divisible by 3. Oh my god. Wait, sorry. It's other goes under. It should be 15 over 12. Whoopsie daisy. Sorry. Happens to me too. So this is a good way of showing you even someone who's done it a million times will still mess it up if he's not thinking carefully. Other goes under, so 15 over 12. I can still divide both by 3. It's 5. That's 4 when divided by 3. Uh-oh. I got 5/4 here. And then I'll have 4/5 on the other side. I apologize for my mouse being loud. I heard one of my recent videos. My mouse is pretty loud. It's just because my mic picks up a lot, and I can't seem to figure out how to turn that down. It's not a good enough mic that it'll pick up only my voice. Apologies there, guys, if you want to just, Venmo me or something. I don't know. Then maybe you can help me get a better mic, but I'm waiting on that new stimulus check to help me get a better microphone. Okay. So 4/5, 5/4, 5/4, 4/5. Oh boy. So I'm just comparing these two and these two. Luckily for me, I can tell both times that 4/5 is less than 5/4, because 4/5 is less than 1, and 5/4 is greater than 1. So that would tell me that XYZ has the comparative advantage in the production of cars. Again, this is a really good thing for you to do. Some of you guys will want to save time, not want to write the 1 car equals thing, and you'll just write the 4/5 P thing. You will make mistakes if you do that. I write it this way for a reason. The reason is not because I'm extra and want to do a bunch of extra work, like the videos might mislead you into thinking that I love doing work all the time. No, I like my job a lot, but like when it comes to doing like unnecessary work, I don't believe in doing unnecessary work. I write out the formula every time because it helps me say out loud in my head, the opportunity cost of 1 car is 4/5 of a plane. So if a question asks me, hey, what's the opportunity cost of producing a car in the question, I wouldn't be like, oh, 5/5 of a car. It's like, no. The opportunity cost of 1 car is 4/5 of a plane. These formulas are all what the opportunity cost is. I'm doing that because comparative advantage is who produces at a lower opportunity cost, but the formula is just me writing out the opportunity cost for each of these goods. So writing it out in this formula is not even like helpful, just like the thing you should be doing. Like that's how you should be doing it, because the next thing we'll learn in the next video will kind of be reliant on you writing them in this format. Okay, we'll do one more practice and we'll be done. Okay, you go through this one, just last one for the video. Let's see if you can nail it. Let's see if you can crush it out of the ballpark. We don't have any more problems. Let's see what you got. I didn't bold any words in here, so you have to actually think. The amount of canned olives and olive oil produced from 1 ton of olives. You've got to think, is this an input or an output problem? Is the variable the resource or is the variable the product? If the variable is the product, output. The variable is the resource, it is input. So go through it, reading that statement. What are the product or products? What is the resource? And which one is fixed versus which one is variable? Third one is variable. It'll be that type of problem. So input or output, and then absolute and comparative advantage. And go. And we back. All right. So we're back. Okay. Absolute advantage first. I got to figure out if this is input or output problem before I can do any of that, because if I don't figure out that, I will mess up everything. That's the whole reason why I have to figure out if it's input or output first. If you mess that up, you'll miss every single part of it. So, amount of canned olives and olive oil produced from 1 ton of olives. I see this 1 ton of olives thing. Like, okay, that is the fixed thing. The numbers in the table are the amount of canned olive and olive oil produced. The amount produced means it's the number of things being made. So it's output. So the amount produced is what's changing. It's an output problem. The resource is the ton of olives. That is fixed. It's weird that they use olives for all three. I did that on purpose just to make it hard for you. So, output problem. Who can make the most canned olives? Zaire. Okay? Because again, absolute advantage shouldn't take you long to figure out. Once you know it's input or output, you should be able to do absolute advantage in like a beat. It's like, oh, yeah, they can make more. And then who can make the most olive oil? Yeah, it's still Zaire. So, okay. Absolute advantage for both for Zaire. Easy peasy. Comparative advantage time. It's an output problem. If it's an output problem, class, what's my shortcut? Thank you, everybody. OGO, yeah, we're doing great. Okay. I'm going fast because we've done this a few times. So you just want to probably see the answers already. So the opportunity cost of 1 thing of canned olives is other goes over 10 over 60, so 1/6 a thing of olive oil. The opportunity cost of 1 thing of canned olives for Colombia is other goes over 8 over 24. Be careful, kids like to put a quarter there. It's not a quarter, it's a third. So, the opportunity cost of 1 thing of canned olives for Colombia is a third of a thing of olive oil. The opportunity cost of 1 thing of canned olives for Zaire is a sixth of the thing of olive oil. So I already know that Zaire's got the comparative advantage in canned olives. So quick question, class. I haven't done any of the olive oil work yet. Can I already tell who's going to have the comparative advantage in olive oil? Yes, I can. Remember, I mentioned those sort of like hints before, where they're reciprocals, and you cannot have the comparative advantage in both. Meaning, if Zaire's got the comparative advantage in canned olives, I can already tell you Colombia's got it for olive oil. I don't even need to do math to show that yet. I will to back myself up, but I don't have to. There's a lot of work that can be saved on these problems by knowing those two rules. That the opportunity costs are simply reciprocals of each other, So 1/6 and 6, 1/3 and 3 reciprocals, and that you cannot have a comparative advantage in both. Because if you had the lower number on one side, when you take the reciprocal, it's going to be bigger, so the other one will be smaller. So when you're doing those two hints, the opportunity costs are reciprocals for the same producer. So for Zaire, the opportunity costs for producing canned olives and the opportunity costs for producing olive oil will be reciprocals. Same for Colombia. And then you cannot have the comparative advantage in both. On AP exam questions, when there's one of these, I can almost guarantee you that on multiple choice questions, one of the answer choices will be Zaire has a comparative advantage in the production of both. That is immediately discountable, draw a line through it, literally can't happen. Now, final disclaimer for this end of this video. There is the possibility, albeit rare, that the answer could be that neither has the comparative or absolute advantage. That would be based on them being equal. Like if it was 60 and 60 here, then I would say neither has the absolute advantage of producing canned olives because they are equally good at producing it, right? Neither one is better than the other. You could both have the same opportunity cost, so then neither would have the same. Neither of them would have the comparative advantage. Like if this was 3 in the olive oil chunk here, if it was 24 and 3, this would be a 6th, and that would be 6. Wait, no, 4. Sorry, if this was 4. I messed that up. If there was a 4 here, then it would be a 6th and 6, and then neither would have the comparative advantage because they would have equal opportunity costs. So there is the small possibility, probably like a 5% chance, they've done it once or twice in the AP exam, where you would see neither have the comparative advantage or neither having the absolute advantage. That only happens if it's a tie. In case of a tie, it's neither. But outside of that, you can't have both in comparative. You could have both for absolute, yeah, because that's not a reciprocal thing. It's just who can make the most. And yeah, Zaire can make more of both. That's fine. America can make more than most countries. We have the absolute advantage in most goods. We do not have the comparative advantage in most goods because we have such high opportunity costs because we're so good at producing everything in a vacuum. Okay, so we will end this video there. Let me delete all the massive words and everything. Go back to the bigger camera. Cool. The next video will be over terms of trade. This is the higher level application of this same process. It's the idea of taking the logic that we've just applied and trying to figure out, okay, so given that for Zaire and Colombia, is there a possible trade between these two countries where one makes one good and one makes the other, that they can start swapping and actually both benefit? Because we've mentioned that in the production possibilities curve, one of the things that changes the curve is trade. The idea there being, you might not be able to produce outside that curve, but if you get a bunch of the good from somebody else, you could consume past that curve. And that could help. Yeah, cool. So we'll end the video there. Thank you guys for watching. If you have any questions, as always, leave them in the comment section below. If you want a quicker version of this, there's always AC/DC economics as good review tools, as opposed to watching my entire 45-minute video spiel. AC/DC economics on YouTube, like the band AC/DC. He's got very nice, good, clean, short videos of like the 5 to 10 minute variety that sort of review these ideas. These are the full-on lectures where you first learn them. So when reviewing, I do recommend using AC/DC economics when you're reviewing or looking for someone else's explanation of stuff, because in economics it can always help to have someone else explain it. Cool. Thank you guys for watching. As always, really do appreciate it. Leave any comments you want to in the thing. Thank you all very much, and have a great rest of your day.